So, welcome back again to this lecture on air pollution sources, effects and then mitigation. In this lecture we will be discussing one of the very important topics, urban heat island. So, this is very important topic, that is actually we have especially in the urban areas. All of the urban areas are facing this problem. UHI we call it, or urban heat island. We will discuss the basics of urban heat island in this lecture. Okay. So, in this lecture the way it is planned, I will give you an introduction about the urban heat island, comparison of energy balance between urban and rural areas, why cities are hotter than the rural areas. So, this is because of the urban heat island effect. Then what are the impact of UHIs and strategies, what should kind of strategies are needed to mitigate the urban heat island. So, this is very clear, and it is very clear and established as well, that okay, if you are residing in the urban areas, especially anywhere in the globe, what is happening, the temperature in the urban areas is higher compared to those in the rural areas. So, if you just go away from say 20-30 kilometers to the urban areas, you will find that temperature is very what you call higher, temperature are lower compared to the urban areas. So, urban areas have higher temperature, and this effect is called actually urban heat island. So, in urban heat island, as the name suggests, okay, urban means urban. So, you have urban heat and then we have island. So, this means actually these urban areas are kind of islands which have higher temperature. So, heat means higher temperature. So, the areas are the way it is defined, when a city experiences much warmer temperature than nearby rural areas, it is called urban heat island. And it was proposed by Luke Howard, a British scientist who researched about this phenomena sometimes in 1800s or 1810, when he observed that city of the London was warmer than the underdeveloped surrounding regions. This is actually kind of we are talking about the not in a scale, when we are talking about the not on regional scale, we are talking on a very small micro scale level we are talking about. We are distinguishing the urban and rural areas, and the urban areas are experiencing little bit higher temperature compared to the rural areas. The temperature could be somewhere around between 2 degrees to 5 degrees, even yes, it can be as high as 5 degrees. We work in Banaras Hindu University, and if you go in the university campus itself, even the urban areas itself I am talking about, the Banaras Hindu University campus, they usually have temperature always lower than you just move from the boundary of the Banaras Hindu University, and this is again further we are talking about further narrow scale. Now, the question is, because that is a different issue in India for this one, because when we say that BHU, they have more greenery compared to the other areas. So, if you have more greenery, the temperature will be lower, okay, because plants absorb the radiation as well actually, and then the radiation that is absorbed by the surface, when the temperatures of the surroundings becomes lower, they will try to remit the radiation, and because you have plantation, the absorption of the solar radiation by the surface, earth surface, that will be lower. So, the emission will be lower, and that is why it is actually becoming less temperature in the planted areas or the green belt areas. Where you go in the outside, you see all the concretes, almost everything is concrete. On the roads you see, on the sides, pathways whether you are talking about, you do not find any tree outside. So, the radiation that is actually direct coming to this one, it is directly getting absorbed and then re-emitted. You must have heard about the cases of the Rajasthan in Jaipur. On the top of the what you call their floor or on the chat pe, on the roof, they actually make special kind of paintings, or they paint with the different colors, and these colors are actually reflective of solar radiation. So, what will happen? These colors usually reflect the solar radiation, and then the absorption by the concrete material that is there on the roof, that becomes less, and the walls also. So, if you do kind of painting, the reflection will be much higher, and then if the reflection is higher, the absorption will be low, and if the absorption is low, temperature will be usually low. But now the question is, imagine a situation, this radiation is not limited, to that particular site, even the radiation will be in the vicinity of that one. Okay. So, this is happening in the urban areas. The temperature in the density populated areas, as we said, that it would be 2 to 3, 4, 5 degrees centigrades. In the suburban or rural areas, the variation is mainly due to the heat remaining trapped within locations that often resembles concrete jungles. So, in the urban areas, we have actually like concrete of jungles or jungles of concretes that are made of all the anything you see surrounding us is actually either walls or roads, all the things are there, and the urban areas, the temperature becomes so intense sometimes that even the charcoal roads, they can be actually melted. So, that is also, and that can be a very disastrous. Once they are melted, and when the vehicle are flying on that one, it can re-emit carbon monoxide again, that is another very big problem. So, situation is little bit very different here in urban areas compared to the rural areas. So, there are many complications, of course, there are disadvantages and advantages of the both, but in terms of urban heat highland, urban areas are not good for stay purposes and other things in a way. Okay. So, what is happening here? This is actually it's a profile of temperature. So, you can see here they start rise as you go to the suburban areas. As you move from the suburban areas, the temperature start to rise, and it becomes peak somewhere in the city, peak city in the center of the city, and then it starts sort of as you move from the city away from the city, this areas becomes temperature start to be cooling there, and then if you just go away from the areas, suburban areas, the temperature becomes again less. Now, imagine a situation that all of these are receiving the same solar radiation, 372 watts per meter square. Okay. All of them are receiving the same radiation, which is actually, I am sorry, I should write this again, 372 watts per meter square. So, this area is also receiving the same, urban area is also receiving the same, and this area is also receiving the same. So, you can imagine, just understand the situation, that what is happening. There is in the urban areas, these areas, there is some mechanisms by which the solar radiation is trapped. Okay. So, this now you have to understand that how and what are the materials that absorb the solar radiation. So, we have like you have bricks, they also absorbs, you have concretes which is made of cements and other things, even the roads, they are also absorb the solar radiation. And then another big problem is that these urban areas actually like sort of pseudo you can say environment where the this energy radiation is not transfer is not much actually. So, the energy that is actually staying here, it remains here, it does not go outside, because they are so dense, and they are actually the energy is the energy cannot move from the system, this urban areas, and there is a kind of you can imagine the boundaries, they act as a kind of pseudo boundary where the energy is not transferred to the nearby places, or especially in the urban areas. When you move away from these areas, because why it is not transferred, because you have eddy kind of things, actually eddy circulation is there, the same wind is circulated in the urban areas, the winds are not there that it can be actually. So, the urban planning is now the people are doing that, they are actually designing kind of materials which are which are not very highly absorbing for the solar radiation. So, if they are not absorbing, then they can be using as a cooling agents. And then there are also in the especially in the urban areas, if you go to the in abroad, you see the the high rise buildings, and then in the high rise buildings in between there is a gap. In India, unfortunately, what we have very small houses, okay, one story, 2 story and 3 story. We do not have very big story buildings. So, what will happen? All these actually and there is no space for the air to move. Air containing the high temperature, air mass containing high temperature, they are not able to move from the city. So, they will be containing and they will be actually restricting there, so leading to the higher areas. And India has been witnessing extreme heat island phenomena across northwest, almost like every state, and this actually can cause massive deaths in the urban areas. Even this also has been achieved this, and although it is not intense wildfire, may not be directly related to the kind of what you call urban heat island effect, but when the temperature becomes very high, intense wildfire can happen, and then they can also affect the air pollution as well. So, for example, here you see this is the picture that is shown for the India. This is the Bhiwandi is in Bombay, in Maharashtra you see Bhiwani, and then you have Rohtak here, you have Gohana, you have Sonipat, and you have Delhi. So, the red color means the high temperature, okay, and these high temperatures are actually can be as high as 30-40 degrees centigrade. So, this becomes very big problem. And then the sky blue color means this, you see the sky blue color, you see small patches, these are small towns there actually, to be very precise with you. So, you can see that the small dots, it looks like stars in the sky. So, stars, so many stars are there. One is some stars are very bright, very high temperature here. So, very high temperature in the urban areas and some of the small cities in this one. And you can see the blue part where the temperature can be as about 15 degrees centigrade lower than that one, okay. So, as the size of the now you can imagine that as the size of the urban area increases, urban heat island effect will be increasing, because the energy that is absorbed and not actually transported or moved from the city will be directly proportional to the area of the urban area, the area that we have actually. So, that area becoming very important, and that is why there is also a concept that we should not build a very big kind of urban areas, metropolitan areas. The concepts are there actually that they should be restricted, we have to limit anyway, otherwise what will happen? You see here surrounding areas of Delhi, you see pockets of the high temperature. If they keep extending, this blue will be becoming red actually, and these all the blues will be becoming red. So, as you keep moving, expanding the urban areas, the urban heat island effect is going to be more. So, if you just compare the energy balance, how it happens actually. So, urban areas absorb more solar radiation, and I discussed this one because of the low albedo, okay, because the reflectivity is not very high, low albedo surfaces and limited vegetation, this resulting into higher temperature, okay, increased heat sensitive heat flux, and then reduced cooling from the evapotranspiration, because if there are plants, if the temperature is high, they will try to take water from the through the roots, and they will try to evapotranspiration, so the areas can be cooler. In contrast, okay, so we have reduced cooling in the urban areas, whereas in the urban rural areas you have abundant greenery, and when you have more abundant greenery, it reflects more of sunlight, and this promote evapotranspiration as well, and then dissipates the heat faster. This is very important. Dissipation of the heat is really very important, and like I was talking, that China has developed the technologies that they remove the high air pollution, they blow the winds from one side, okay, during the prevailing wind conditions. Similarly, such kind of things are also, you can imagine, that are needed to dissipate the heat faster. Okay. So, energy content, this is the table showing that different comparison between this one. So, if you just compare in the urban areas, solar radiation absorbed will be higher due to the low albedo, whereas in the lower surface in the rural areas this will be lower due to the intense vegetation. Evapotranspiration will be lower in the urban areas because you do not have plants there, and then less vegetation, and you will have here high. So, this becomes in the cooling. Sensitive heat flux is also very high, and in the rural areas this will be low. Latent heat flux is low. Okay. Sensitive heat flux is actually like the heat that is absorbed in the system, which will be actually we can feel that one. Okay. And then so in the urban areas it will be high, in the rural areas it will be low. So, anthropogenic heat in the urban areas in a way will be very significant, and in the rural areas it will be minimal or insignificant. So, in general the temperatures of the different are different at the earth surfaces, and in the atmospheric air higher above the city. For this reason, there are two types of high, you can call it actually like heat island. Just to give another analogy, if you move to the higher areas like closer to the Himalayas, there you have intense vegetation there. You have in the Himalayas you have third ice, kind of what do you call, we have so many ice in the huge amount of ice in the Himalayas. What it will do? It will, the reflectivity of those ice surfaces are very high. So, when they are actually reflecting the surface, their albedo is very high. So, when the albedo is very high, they will most of the radiation that is actually reflected back, they will not be actually trapped around that place. So, that will be a cooling kind of things. Similarly, in urban areas the cooling mostly happens because of the plants, but we do not have plants actually in the cooling which can do cooling, natural cooling. So, that is why you have high temperature. So, surface heat island, these island form because of the urban areas such as roadways and rooftops. Okay. So, this is just because of the surface, and then and they emit heat to a greater extent than the natural surfaces. On a warm day with the temperature about 91 Fahrenheit, you can calculate in the degree centigrade. Conventional roof topping material may reach the temperature about as low as 60 degrees centigrade. Okay. Surface heat island tend to be more intense during the days with the high sun shining. So, when the sun is shining actually. So, because when the sun shine is more, you are having more of the solar radiation that is reaching on the surface, and now you can see, if you just remember this one, in urban areas even in the winters. So, in the other day, in the normal day, the nights will be warmer compared to the rural areas. So, urban areas, even the winter is there, for example, we are in the December, we do not feel so cold this time. Okay. And not only this time, actually the colder, of course, that is a different mechanism, we are not going to end those debates, but the temperature here is much lower compared to the rural areas. So, you just go to rural areas, you can feel the temperature. Then the other type is actually surface atmospheric heat island. These heat islands form as a result of warmer air in the urban areas compared to the cooler air in the outlying areas. So, atmospheric heat island vary much less in the intensity than the surface heat island. So, this is very important, and I know because the hot winds will be keep on circulating. For example, what you do in a system, you are just putting a blower there. Once the temperature becomes a temperature becomes significant enough that you feel comfortable, the same air will be circulating. Okay. So, this is like urban areas, the similar kind of mechanisms are there. So, if you just see comparison between atmospheric UHI and surface UHI, temporal variations, atmospheric UHI is much less, and this is a small maybe non-significant during the daytime, high intensity at the night time and in the winters. surface UHI, this will be actually high intense, and this will be during the day and especially in the summer. So, in the in the winter time, urban heat island has two types of different effects, atmospheric UHI. So, because of the wind circulation, they will be actually keeping the surface warmer, and you remember that during the winter season the temperature is usually the wind speed is usually lower. So, when you have lower wind the circulation or the dissipation of the energy that is contained in the urban areas will be again lower. Okay. So, surface versus atmospheric temperature variations. Surface temperature fluctuate more than atmospheric air temperature during the day. Okay. So, we are talking about the temperature, that how the temperature actually vary. So, surface temperature will be varying more compared to the atmospheric, because atmospheric air is some sort of kind of stable, because it is not and then at night surface and air temperatures are generally similar, but it is not the case in the urban areas. Water temperature stability, water in the ponds maintain a nearly constant temperature day and night. So, this is one of the reason that many of the cities they need to have the ponds, because if you have ponds, there will be like the evapotranspiration can happen from the plants, but if you have pond, the kind of water vapor that can be formed, and those water vapors will be actually kind of those water can absorb the solar radiation, and once they absorb the solar radiation, higher energy molecules they will go into the atmosphere, but since the energy is already absorbed by these water ponds, what will happen? The temperature of the atmosphere will be cooler, and then cooler effects on the natural elements like parks, open island, bodies of water creates cooler than the cooler areas within the city. So, this is very important. So, if you want to have low temperature in the urban areas, you need to have actually like parks, open lands and water bodies that can create this one. Okay. And suburban rural borders are typically cooler than the downtown areas. So, this is also very important here. And these are the images that you can see. This is Washington, and then this is the temperature, this is vegetation, sorry, this is vegetation and this is the temperature. You see the vegetation, the areas which has high water content, you see here, the temperature are relatively cooler here in a way. But and the areas where you have plants, the temperature are usually cooler. So, if you have more plants in the city, the atmospheric temperature will be cooler, but you can see within the city there is a huge heterogeneity in the temperature even within the city. So, what are the why are cities hotter than rural areas? They have less green cover. Okay. So, there are reflectivity is also low, as well as the evapotranspiration is also low. So, they usually urban areas have very kind of high temperature. Transpiration is also a very important natural way to heat regulation, and this is scientific process of roots absorbing water from the soil. So, when the temperature is more, kind of like in the summer season we becomes more thirsty, so we need more water intakes. Okay. Similarly, when the temperature is higher, the plants will try to get more water, but where is the water? The water is actually through the roots, they will bring the water, and this transpiration will be more, and then sorting they will be living in the leaves, stems of the plants before processing it and releasing in the form of water vapor. So, because you do not have plants there, transpiration is actually not there. Heat regulation, urban areas are often developed with high rising building, roads, parking space, pavements and transit routes for public transport, and as a result heat regulation is either completely absent or man made. So, kind of anthropogenic again here. The construction is very high in cities, usually they have high building constructed like with the glass, bricks, cements and concrete, all of which are dark color material, meaning they will attract and more absorb more solar radiation and heat content. So, this is actually kind of the factors that are affecting the UHI. So, what can be the effect of or impact of UHI? So, energy cost, urban heat island increases energy cost. Okay. because if the temperature is high you need air conditioner. Okay. And then at the same time when you are putting more of air conditions, you are actually putting like you are taking more energy, and then those energy will create the pollution problem. Of course, not from here actually, but you have to from the thermal power plants or anywhere you have to generate the electricity. So, those kind of things also is becoming very important. Then poor air quality, because they urban areas usually have very lower air quality because there are more pollutants, waste products from the vehicles, industries and peoples. Then you have poor water quality also. Water quality is also, although there is no direct link between urban heat island, because how it can actually affect, but it is mostly because of the water that is there that we consume, and then drainage system is not proper. So, that the nearby what you call area can be groundwater that can be actually affected. So, they can reach into the groundwater, okay, aquifer zones. In the aquifer they can reach in the aquifer and then they can be affected. So, colonized by heat loving species, they will have more of heat loving species in the areas, and then heat waves. This is very important actually. In the summer temperature becomes so hot that it becomes very difficult for daily persons to walk or even bike. Yeah. So, heat island effects in increased energy consumption, okay, because of the heat island effect, and we need to have more energy, and we need cooling things, we need to cool the water as well actually, because the temperature is high, very high. So, we need cold water. So, that kind of also things will be there. Then elevated level of air pollutants and greenhouse gas emissions, because companies that supply electricity typically rely on the fossil fuel power plants to meet such energy demands, which in turn lead to the release of air pollutants and greenhouse gas emissions. So, then compressed human health and comfort, this is also very important, that this will be affected because the cities were causing widespread discomfort, respiratory problems, sunstrokes, dehydration, tiredness, and even increasing mortality rates due to heat strokes. So, these are the effects of heat island that can be caused because of the just heat, excess heat that is absorbed in the city or the urban areas. So, in this lecture I think I was probably able to give you some idea about the urban heat island effect and how it can be actually impacting the people, the environment, and then the living beings in the why it could be sensitive for some of the species who like hotter temperatures. They can be actually good for them, but others it will be very difficult for them to survive. There are lots, you do not have in urban areas we do not have actually things which do evapotranspiration or transpiration like plants or the natural lake water or pond water. They are not there, they are absent. So, because of that also the temperature becomes higher. So, I think this was actually very basic lectures, maybe we will have more scientific lectures on this one, and I hope you get some idea. I suggest you again to read these things, the equations that are involved in this, and then we will discuss more in the coming lectures. So, thank you so much and enjoy. I hope you enjoyed the lecture and keep studying. Do some kind of homework, read more, study more, get some more material on this one. It's just these lectures are just giving you some ideas. So, you need to, if you want to have a very good comprehensive understanding, you need to study well. Okay. Thank you so much. Bye. Take care.